I guess you guys want to see it too.
What I'd like to attempt to do is a speedrun of a challenge. So I picked this challenge that you can look at on the internet if you like. There's loads of them, like older ones, part of a recruitment campaign. But I picked this one. So I'm going to try now to solve this challenge and hopefully try to tell you what I'm doing as well. So let's go. So first we make this a bit shorter. There we go. So we've got a README. What's the README say? The README basically says, I've read this before, it says Dr. Evil has a password archive inside a load of zip files and he's forgotten all the passwords. It's your job to find them. The first password is in clear text and then there's a mysterious hash here. So, well, since they say the first one is in clear text, let's just try that. Looks like an MD5 hash. Let's just try the README file as the word list. Did I do something wrong? Yes, I didn't specify actually the hash, so sorry. Raw MD5, sorry. Oh, I'm a bit rusty here. I'm a bit nervous as well. There we go. So that should be the password for the first one. So I'm going to type stage a lot of the times when I'm supposed to be typing steg, so you'll have to excuse me for that. So that looks like a really big file that's being unpacked. Let's just have a look at what's in there. It's still unpacking. Maybe I'll try this first. Okay, so it looks like an NTFS file system, and it's probably worth finding out what's in there. So I'm going to prepare the mount command. And also, while I'm waiting for this to unpack, the README said that along the way, we're not only looking for the password to the next zip file, we're also looking for pieces of the passphrase that's used to unlock the password vault at the end of the challenge. This is taking some time. Yeah, so we can deduce that this is going to be mostly repetitive data because the zip file I downloaded was about 70 or 80 megs, and now it's up to, yeah, 8 gigs of image here. So there's not going to be much in here. We'll have a look. We'll copy all the files over. So now we have a PDF, and we have the next stage, stage 3. There we go. So let's have a look at that. Oh, go away. Let's have a look at that PDF. Yep, looks like a PDF, all right. Nothing weird before the header, so let's have a look at the end. Ooh, there's something weird. And this looks like a hex encoded string. So we're just gonna, here we go. So string is, there we go, hexlify. Oh, this is going really slow, I'm sorry. Let's see, we've got our, oh, that's a base 64 blob. Take that. Decode that. Oh, interesting. So this looks very much like a rotated cipher. We could probably guess that this is like an I or an A. We can see the word separators, so let's try. I hate this thing. no, that's the wrong way around. Oh, there we go. Yep. So that should be the password for the third step. So let's see. Did I have that? No. All right. You always do that before because they've been sneaky, so it's actually just a 7-zip file again. So put in the password, and we should get the next stage. Let's hope this isn't that big. New directory for that. Okay, so we've got a raw file. We have something else in there. Ah, so we got a PCAP. Nice. Wireshark. Let's go. So the first thing you want to do in Wireshark is statistics, protocol hierarchy, which will show you the breakdown of what kind of protocols are in the dump. So we've got some interesting stuff here. Hypertext transfer protocol, lots of that. Some SMB traffic. Oh, FTP data. Interesting. Let's look at that. Final password.txt. Ooh. Okay, so there we go. We have some data there. I'm going to... why can I do that? Copy. Value. There we go. So let's start a new file here. Oops. Saving the bits of the passphrase in there. So I'm going to do like that so I don't forget to do that last time. Okay, so FTP data, there should be a control session for that as well. Let's see what's in there. Dr. Evil logged in. Cool. Password required for Dr. Evil, pass mini-me. Okay, well, that's interesting. Okay, so we could probably have a look at what... we should probably have a look at what else is in there except the FTP data. So this is going far too slow. We had some HTTP traffic. Let's look at that. There we go. Okay, so we've got some surf traffic. Oh, Dr. Evil is apparently leaking anti-LAMP credentials. That's interesting. So let's find a way to extract those from our NTLM SSP PCAP. There we go. That looks like it might work. Just copy some stuff off of GitHub, run it on my machine. What's worse that could happen? So, did that actually? No. Frick. No. Maybe. There we go. Damn it. I was typing much faster when I tried this earlier. So, yeah, we'll see. Python. Okay. Thank you. So he probably wants the PCAP. There we go. Ooh, perfect. It's dumping credentials, so let's save them. So there was also a hint in the README file I forgot to tell you about earlier that said that he likes to reuse passwords, this guy. So, oops, I'm going to... just make a quick word list. Okay, so it's netNTLM v2, right? And we have our creds, and we have a word list, which is called P, and let's run some rules on that. I don't know, do we have a... let's just run the standard rules. Didn't work? No. Okay, so some more complex rules, perhaps. The core logic ones are good. There we go. Perfect. Okay, so we had step 3. Let's assume that's also not a RAR, but a 7-zip, and yes, it is. Sneaky fuckers. There we go. And now we have our oops. Next stage. Okay, so DMP file. What the hell is that? Oh, that looks like a crash dump. Interesting. Let's have a look at that. Genuine Intel. Ooh, lots of Microsoft libraries. Okay, so if this is a crash dump of the LSAS process, there should probably be some nice stuff hidden in there. So let's use our old friend Mimikat. Let's copy this over so we can run it on a Windows machine. Jump over to a Windows machine. Let's have a look in here. Oops. So Win32 Mimikatz. Okay, so secure, let's say mini dump. Yeah. What's it again? Is it logon passwords? Yeah, there we go. Okay, so I'm going to have a look at what is in here. Lots of fun stuff from LSAS. Okay, so we've got another piece of the final passphrase there. Some more stuff. I'm just going to take a copy of that quickly, run over here, put it in our file perhaps. There we go. So, and the FTP stuff that we saw is part 3. So we've actually missed part 1 and 2. So let's go back to that later on. We see that this is probably part 4. And we need the password for the next stage. Let's have a look. Do we have some more passwords? That's a null password. Dr. Evil. Yeah, we know that one already. That was for the last one. Stage 5. Throw me a fucking boat here. There we go. Ooh, baby. Okay, so let's hope that's a 7-zip file. Yep, it seems to be a 7-zip file still. Okay. I don't know how I'm doing for time, so you're going to have to kick me off when I've had too much. 5. Ooh, VMem. Interesting. Let's have a look what's in there. Yeah, looks like memory from a virtual machine, all right. Interesting. So let's use our favorite tool, volatility. Let's see if I can remember what to type as well. Is that right? Yeah, I think so. Yeah, there we go. So that's memory dump, raw, sorry, physical memory dump of a machine that we can look at through volatility. So what's in here? We've got lots of cmd.exe. That's interesting. We've also got a notepad. So yeah, I know there's a notepad buffer search in volatility. Let's have a look at that. Yeah, there we go. Let's save that for later. Let's have a look at those CMDs as well. Oh, now I can't remember what it's called. There's a CMD scan, yeah. Let's have a look at what they've been typing into those cmd.exes. That might be interesting. Okay, we're almost there, because it says last, and I don't think last is an archiver. I think this is probably a 7-zip again. Yeah, looks like it. Okay, so we've got a lot of commands here that have been... Oh, there we go. Frickin' long password that can never be cracked. How about that? Let's try that. Yeah. Okay, so stage 6. I'm actually not typing stage all that often. That's cool. So reverse me.exe and keys and secrets to the underground layer. Okay. So here's our final destination. And I'm going to guess that's the last part of the passphrase for this. So we probably need to get the 7-zip password for this archive from reverse me. Okay. Let's have a look. So let's run the IDA demo. Projects. Reverse me. Let's have a look at there. Okay, now I remember what I forgot to do. What you always do is look what kind of files they are. So because I know that this is going to be oops packed file, but that's okay. Just do this. There we go. Now let's go back to IDA. Come on. Reverse me again. There we go. Okay, so now we have something. Okay, so we're reading something from input. We've got a loop here. That's nice. Let's make this a bit bigger so you guys can see it. And we're XORing the input. Let's see. 20 times loop goes round and round. We're XORing something with this. Okay, what's that? And we're comparing to get to the right password. We follow this branch. So we're going to fall out the loop if we've got the wrong thing. So let's have a look there. So yeah, there we go. You probably can't see this because I can't make it any bigger. That's too bad. But here we have some hex data. Okay, I'm going to copy that over to somewhere where you guys can see it. So we had a nice nice bit of hex data there that we're XORing the input string with. We're XORing the input string with something and comparing it to this value. So if we XOR this value with the stuff that we're XORing the input string with, then we should get what the input string should be, right? With the commutative properties of XOR. So let's go back, have a look. What are we actually XORing this stuff with? Okay, we're actually XORing the input string with the loop counter. And the loop counter is initialized to be 20. And it's incremented each time we go down. No, it's not incremented? That's weird. Am I being blind here or what? No, it's not incremented. It's actually updated to be the value that's in here. So I can probably do that in Python. Let's have a look quickly. From bin ASCII import all unhexlify. And it doesn't like the spaces, so this is crap, but I have to go through manually and take out the spaces. I'm probably way over time already, but we're almost there. Almost there. Okay, so let's have our loop counter, which was initialized to 20. For character in X, do. Okay, so let's see, we had the character was supposed to be replaced with the character XORed. I can't find the keyboard. There we go. With A. That was right. wasn't it? And then we update A with the new value. I think that was right. And of course we also want to print. Oh shit, I've done something really stupid. We need to do this as well. So yeah, let's just go back and oh wait, that should be in the buffer already, right? So actually I might fuck this up for you. Sorry. Sorry? Oh shit. Yeah, that's right. That's right. And also we want to print. Now my phone's ringing in the middle of this. That really sucks. And why did I print F? There we go. And then A should be set to to the ord of C, which is already ord. There we go. Is that correct? No. Sorry, I fucked up. Have to look at this again. There we go. So we're actually loading the value each time, and it's going to be the offset plus 20. So that was my mistake. Sorry about that. Should have rehearsed this better, actually. So let's do it again. There we go. And for each in C, and then I've already fucked up because A has to be 20 already. So A equals 20, and for C and X, we do print the character, which is the order of, or the ordinal of C, and we XOR that with A, and then we update A to be A plus 1. Sorry, that was the algorithm. And that should do it. There we go. Boo frickety hoo. Okay. 7-zip, extract, stage 6, final password. Boo frickety hoo. There we go. Okay, so now we only have the last piece of the puzzle, which is the first two. So let's have a look at that big freaking image again. Or actually, let's do a strings of that again. That big freaking image that I didn't really have time to look at before. And while we're doing that, we'll do this. Stop ringing, stupid phone. Okay, so we've got number 3, we've got number 4, and then we're missing I really should have rehearsed this. From 5 and number 6. So we're missing number 1 and number 2. Okay, let's go back. Have a look at the big NTFS image, if there was anything interesting hiding out in there. Ooh, there we go. That looks like number 1 and number 2. Yes, it is. So, again, let's reconstruct this lovely passphrase. And it's going to look something like this. You know, Scott? I've been a freaking evil... Evil what? Evil... doctor for 30 freaking years. Yeah, we know. Okay, cut me some freaking slack. You forget, Scott, we're in a volcano. We're surrounded by liquid hot magma. Oh, frick. There we go. So yeah, And that was the last one, wasn't it? Number 6. So let's just take everything else away. There we go. And for the last piece of the puzzle, this isn't actually going to work. I know this since I've tried this before. If you Google this passphrase on the internet, you'll find lots of quote databases. And the quote won't work unless you correct the punctuation. So there's supposed to be a comma in there as well. Easily found by Google, but I'm not going to Google it now because we don't have time. So let's see. It was a KeePass database. And there we go. And we need to pass. There we go. Come on. No. Paste. There we go. We're done.